kind of funny quizzes in my back pocket. No. Oh yeah, here we go. Brittany Crow. Lance. Sierra. No. Art Badger. Taylor. Yes. Whoa, that's all crooked. Shoot. All right, guys. So that was an easy question. I like that one. Anything else? You guys all right?
12.6. It's 28, 31, and 34. I'm just not getting the concept of that.
All right. All right, so let's look at 20. That's the one where they say a single die is rolled.
Yeah, 28.
28?
Yeah.
Oh, so that's the one with the monkeys and the lions.
Uh-huh.
All right, so, and there's two parts to each question. There's a part A, part B. So, let's see. Can't trust those. So 28, section 12.6. This is where they get the cards with birds and lions and so forth. 28 says they both show the number 3. So there's, what is there, 20 cards? And they're 1 through 5. And some of them have lions, so forth, whatever. So 28, part A would be with replacement. Part B is without replacement. I'm picking 2 cards. They both show the number 3. So it's probably the first one shows the number 3. So there's 20 cards. There's, we'll call them 4 suits. Right, so there's birds, lions, frogs, and of course monkeys. Right? This is for the really high stakes poker. They play with these instead of clubs, boring clubs and shit. Right? I'm gonna win with a full house of freaking animals. So there's like a 2 of birds. There's a 3 of monkeys. There's a whatever. You with me? Is that you guys kind of with me? So how many 3s are there? 4 3s, right? Every animal has a 3, 1 through 5. So I got 2 cards I'm going to pick, and I'm doing it with replacement first. I'm going to put that first card back in. So what's true about the denominators on both of the probabilities that I'm going to write? What must be true? What's the denominator on the first guy? Getting a 3. What's going to be on the bottom? 20, because there's 20 chances. There's 20 different things that could happen. There's 20 cards. Out of those 20 cards, how many have a 3 on them? 4 have that, right? And I want to get another card with a 3. It could be the same one because I put that bad boy back in. So what's the probability that the next card is a 3? Same thing. Then multiply. Is that cool?
Okay.
All right, so far so good?
On 31, I actually looked at the answer because I was like, what the heck? So we're same thing, you're going to multiply it 16 over 4.
So here a yellow bird and the second shows a frog. And only 2 of the birds are yellow. Right? Alright, so this one would be 1/5, 1/5, 1 over 25, right? And real quick, without replacement for the same problem would be, well, there was my 5th puberty. 420 times, I threw that one away. So how many 3s are left? 3. And how many cards are left? 19. So the next one's 3 out of 19. Or whatever the hell that is. All right. So that's how to finish out that problem. With replacement means that the probabilities stay the same in each stage because you keep putting it back in. Without replacement means you take a card, you throw it away, you take a person, you put them somewhere else. Right? In statistics, we can actually pick the same person over and over again. We let that happen because it makes all the math easier. You can see that happening right here in this little tiny problem. So on 31 it says yellow bird, right? Yellow bird.
And the second shows a frog.
And then a frog. That age-old question, what's the probability of this happening? So again, I already told you how many yellow birds there were. You can see there's only 2. So the first probability for part A is 2 out of 20, because there's 2 yellow birds out of 20 cards. Is that cool so far? Put that card back in. How many frogs are there? 5 frogs out of how many cards? Okay, cool. Right? So that's 1/10 times 1/4. You get 1/40. Now what would part B look like? Part B has the same beginning, because you haven't done a damn thing yet. At that, now I picked a card. I picked a yellow bird, and I throw that yellow bird away. Right? Because I'm callous like that. How many frogs are left? All 5. I like it. How many cards are left? 19. So it's be 5 chances out of 19 now to get a frog. And then whatever the hell that is. Cool. I like it. You guys get the idea. So a lot of the math we do in this class is not really intensive. It's just different than what you're used to. And if you never had probability before, it's definitely different. Right? But it's actually, probability can get pretty gross, but the fundamentals of it's pretty straightforward. It's just counting. It's all based on counting. So if I put something back in, the numbers don't change. If I take something and take it out and then do something, now the numbers have changed. I like it. Cool. Why did that top change, but this top didn't change? See how this top changed? Why did this top not change? Different kind of card. There's all 5 frogs left. Up here, what did I pick? I picked a 3. And I threw it away. So now there's only 3 3s. Oh, shit. Or 3, whatever it was.
So does the same concept work on 79 through 84?
Let's see. For some of them, the difference on number on that one is you're not picking 2 things, right? So let's see. Number 79, for example.
79, I think is straightforward.
Okay. So which one?
81.
81? Okay. 81. So this section of homework says there's a 5-question multiple choice exam. Blah, 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 blah. Has 4 possible answers. Gershon Salk, of course. Meg's friend, and he knows Bob. Meg and Bob and Gershon Salk. Related. I don't know if he's related. Picks an answer at random for each question. Determine the probability he selects correct. Okay. So, when they say, on 81, they say, what's the probability that it gets the right answer, the correct answer on the 3rd and 4th only? Which means, what happened on the 1st, 2nd, and 5th? So how many, why did I do 2 things here? You guys see how I had 2 underlines, 2 blank spots there? Why were there 2 blank spots? I was doing 2 things, right? How many things am I doing here? How many times do I have to choose something? How many questions on the test?
5.
5 questions. So I'm going to do 5 choices. You with me? No. So this is the beautiful thing about this kind of thing. If I picked 5 cards, I would have 5 underlines here that I have to fill in with probabilities, right? So here I got 5 questions. So I got 5 little hangman game things here going on. I got to fill them in now. Why are they all connected by multiplication? Because I want to get, the first question I want to get what? To answer this question. As the person, I don't want to get any of them wrong. But to answer this question, what's going to happen on the first question?
You got it wrong.
I got to get it wrong. And I want the second question to be
Wrong.
and 3rd and 4th to be Right, and remember, what does and fundamentally mean? And means multiply. Right, that's why these kind of problems are going to be connected by multiplication. So this problem is exactly the same as this problem. So, if I do something on the first question, does that affect the next question? Do I have less choices in the next question? You see, if I pick a B, can I not choose it for the next question now? Of course I can. So they're independent from each other. So it's going to be more like this one. They're not going to change. So what's probably the first one is wrong? Yeah, out of 4 answers, how many are wrong? 3. So what's probably is wrong? 3 out of... No. The 5 questions did what for me? What did the 5 questions do for me? It's set up by 5 spots, right? Each question has to have something happen, wrong or right. I'm going to fill in the probability of each. That 5 is done. What are the probabilities going to be based on now? The fact that there's 4 answers for every question. So it's probably I get the wrong answer on a question 3 out of 4. 3 out of 4 chance to get the wrong answer. So I want the first one to be wrong. What do I want the second one to be? First question, second question, third, fourth, fifth. Second one, I want it to also be wrong to answer this question. I'm not some student who enjoys getting low grades. Please let me get the second answer wrong. So that's 3/4 again. And the third one, I want to be right. So it's probably that the third one's wrong. It's probably that it's right now. 1 out of 4. It's probably the next one's right. And the last one's got to be 3/4 because we got to be wrong. I like. And they multiply all that stuff together. I'm going to get something. All right, it's really going out on a limb. You get something. Yeah, 3 times 3 times 3 is 27. And 4 times 4 times 4 times 4 is 1,024. So the chances of that happening seem to be pretty small. Why would you want to know that? I don't know. The book did. So let's do it to get used to how to do these kind of problems. As a student, I would be more interested in what's the probability to get them all right. All right, did they ask that question? No. The correct answer, number 82 does, but I might not have assigned that one.
You did.
I did, there you go. So that one says the correct answer on all 5 questions. What's the probability he gets the right answer on all 5? Then all 5 would be, careful, he gets the right answer. So only got a 1/4 chance, right? As a student, you know that feels right. There's 1/3, there's like 3 times the chance to get it wrong than it is to get it right. Sort of like going to Vegas. Right? So 1/4 shows up 5 times. That's a quick way to do that. You see that?
So was it just the opposite then on the 83? Where they'd all be 3/4?
Yeah, the correct answer on none of the questions means they're all wrong. So you just fill them in, yeah, exactly. So it'll be 3/4 to the 5th power. But if you only had to get one right, did they ask this question? No. Let me see if we can get this. What's the probability he gets at least one of them right?
It's 84.
Huh?
That's the last one.
Ooh, look at that. All right. Just didn't look far enough down, Jim. So that's awesome. That's a good question to ask. Probability at least one right. If you try to attack this straight on, that would so desperately suck. Because how many ways is there to get at least one problem right? You get the first problem right. Let me just do it like this. Can I just do right, wrong, 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 wrong? Right? That's one way to do it. So I'd have to do this. It would be 1/4 times 3/4 times 3/4 times 3/4. You kind of with me? Mm-hmm. Or, and what's or mean?
Plus.
Add. You could do the second one right, or the third one right, or you could do 2 right, because what's at least 1 mean? 1 or 2. First 2 right, or the first one right and the middle one right. Or maybe 3 right. Or maybe the last 2 are right and the first... Holy shit! Please tell me there's an easier way. I don't know if you guys understand what's going on. Some of you guys are like, what the hell do you want me to do with that shit, Jeff? What is this? You're taping yourself and you're doing weird shit. I'm like, yeah. There's a better way, of course. What's the opposite of at least one right? What's the opposite of getting at least one right? No. What's the opposite? If I wanted to, if somebody said I got at least one of them right, how could I show that they're wrong? That's not correct. The only way to do it is if they got all of them wrong. Therefore, I want you guys to get this. The probability, what's this R? Of at least one right, since it's the opposite of none right, don't we know that? That's how opposite probabilities act, right? One is going to be one minus the other one. And how many ways is there to get none of them right? How many ways is there to do that? How many ways is there to get none of them right? One way. I like your reaction. There's a hell of a lot of ways to do this shit. If you want to do this, that would take forever. So here's the neat thing about probabilities. Whenever the opposite probability is easier to calculate, dear God, do it. And then do 1 minus what you got. Because that's going to be back to the original, right? In fact, this is number 83. That's the one we just talked about. That's this guy. 82 maybe? No, 83. So what's probably get none of them right? That means they're all wrong. Oh, that's number 83. It is number 83. Yeah, so it would be 3/4. So it would be 5 of these bad boys, right? Is that cool? If we get none of them right, it'd be 3/4, 3/4, 3/4. This will probably get them all wrong. So 1 minus that is going to probably get at least 1 right, which is actually a decently large probability. What is that?
243 over 1,024.
Do 1 minus that, right? Yeah, you did 1 minus that yet. Right. I think it's 781 over 1,024, which is whatever. It's like 77%, 70 something.
76.
76%. Which is pretty good. Pretty good odds, right? If you just had to get one right to pass the test, and you just guess, you got a 75 greater than 3/4 chance to pass just by guessing. You know, that's not a very high standard. Just got to get one of these right, and then you can walk out the door. The first question is, "What's your name?" Oh, okay. All right. Anything else from anywhere? I never know how to read you guys. Is it because you so don't understand stuff you don't even know where to start? Or is it all just too easy? Or you just don't like talking to me?
12.7. 12.7, number 6.
You saved me. I was going to break down.
Don't do that.
Oh, all right. So this one is a little weird.
Yeah.
So if I said somebody comes in here and picks a person, given that the person is sitting down, what's the probability that they picked the teacher? 0. Why? Because nobody sitting down is a teacher, right? So this is exactly this question. It says, so they have these balls, 1, 2, 3, 4, 5, 6, and these two are yellow. All right, because they just turned around and ran. They're yellow. What's the probability then if I pick up one of these at random that I get a 5, given that it's yellow? Well, let's set this up. Let's use the formula. On the bottom goes what?
2.
Why 2?
Because there's only 2 yellow.
Beautiful. Given that it's yellow, so how many things could it be? 2. Right? And on the top goes how many of those match what I'm looking for?
0.
How many yellow balls match me looking for a 5?
0.
None of them. There you go. So none of them, so it's 0% chance.
Okay, I'm just making sure.
Oh yeah, okay.
It's just
Cool.
too weird.
It just sounded weird. Yes.
Whenever we do probability, do you want us to take it to a percent or leave it as a fraction?
I need to see the fraction because that actually is the work. And a lot of times that's the work. And then whatever you do after that, I don't care, really. Unless I tell you at the top, I'll say, write as a decimal to the thousandths place or something, right? But your work is going to be the fraction. Don't just give me a number of decimal or percent out of nowhere. Because if it's wrong, I'm going to have to take off a lot of points. And if it's right, I'm still going to probably take points off because I'm going to say there's no freaking word here. Does that make sense? So here, the work would be this, and then, of course, that's 0. Yeah. Or you just explain, ain't no way, Jeff. That's all right.
What number was that?
6.
6, yeah. 6 and 12, 7. Can you guys answer 9E okay on the practice test? What's up?
We did in class.
Oh, we did?
Yeah.
Sweet. I forgot. It's been, what, a week? Over a week?
Do you think you could do like a similar problem to this?
To number 9?
But you haven't had anything.
Oh, sure. Okay. So, let's see. Let's do men and women. Yes. No, maybe. I'll let your imagination come up with what the question was. Whatever it was. So any of this kind of question, what should you do first? Even before you look at the questions. What's the very first thing you should do?
Make totals.
Make totals, because the probabilities are all based off of counting off the totals. So I got 14. 14 what?
Yes.
Good. For some reason, people can't read this correctly, and I got to remember, I'm really used to these kind of, this is called a contingency table, and you set these things up all the time. If I get people tell me 14 men, I'm, no. How many men were there?
17.
Still don't. Please don't make me dance anymore. If you want to call it that. And then how many women were there?
23.
23. I heard some of you guys starting to go, that was what? 45, 21, and then you just make sure, do those add up to be 40 also? Yes. Thanks for that. Thanks for helping me out. Is that cool? And why do you think somebody might put an 80 here? So you saw those people and saw those people, but those people are those people, right? So don't add them all together twice. Okay. Good for voting, right? Vote early, vote often. So what's the probability from this group of people, whatever the hell's going on here, that I pick a woman? I'm building up to this question, by the way, whoever has to be.
23.
Yeah, beautiful. There's 23 women out of 40 people. So what's the probability that I pick a man or somebody who said no? So you got to take all the men. There's 17 men. And then you got to take all the people who said no, but if you add these two numbers together, what did you do wrong? If you add these people to these people, you added those people twice. What the hell's up with that? They don't get a vote down. So I could do this. I could say all the men and all the people said no that I haven't counted yet. So 17 plus 19. Or I could do 17 plus 21 minus 2, which is what the formula says to do, right? Probably 1 plus probably the other minus any that are both, because you counted them twice. So either way you do it, you get 36 out of 40. Which you can reduce and make a decimal, whatever the hell you want to do with it after that. It's up to you. Cool. So, what's probably as a woman given that they said yes? So what goes on the bottom? What do you know about the person? What were you given? What information were you given? It's not, I didn't tell you it's a woman. I told you they said yes. So the probability it's a woman. Given, they said yes. So the bottom is always going to be related to the second part. All right, so what goes on the bottom? 14. 14 people said yes. So if I tell you the person I picked said yes, it can only be out of the 14 people, right? So out of those 14 people, how many match what I'm looking for? 3. All right, how are we doing so far? Those are exactly the kind of questions. You know I'm going to give you exactly a problem like this. It might not be men, women. It might not be yes, no, maybe. But it's the same damn problem. Just different labels. Right? I'm going to ask you all these kind of questions here. I'm going to ask you a question like this and a question like this. Because it's going to lead to this question. Are being a woman and saying yes to whatever this question is, are they independent? Take it. Independent is a risky word. Sometimes you forget when to stop. Like banana. Mississippi. So are being a woman and saying yes independent. And I kind of like reading the paragraphs that people give me about their thoughts. But math is required here, right? You have to use math to answer this question. You can't reason it out. You can't, because it's a mathematical idea. So what's probably this woman just by itself? Just probably get a woman just by that by itself. 23 out of 40. Which somebody on the end. That's about what? 57%. Yes? 57 roughly?
57.5.
I'm sorry. I'll resign. So 57.5. And what's this? This is obviously not that, but what's 3 divided by 14? Somebody help me out. So about 21%. Okay. So, did knowing that the person said yes affect the chances that it was a woman? What would you say? What's your gut say? If I knew the person said yes, did the probability they're a woman change? Because what was it before? And what is it now if I know they said yes? 21%. Therefore, what would you say? Would you say that these are dependent or independent? What's your gut tell you? What makes sense? Do they affect each other? What was the woman before? Probably a woman. Did it change?
Yes.
So did this affect this?
Yes.
Therefore, they're dependent, right? Dependent on whether they said yes or no. It changes the probability it's a woman. Just like, I don't know if I think I gave you this example because I gave it to my stats class too. If you see somebody in the distance, and I'm talking about this, and they get off I said it's a 50-50 chance it's a man.
Yeah.
But I saw them get off a Harley motorcycle. Now it's a higher probability it's a man. That does not say no women ride Harley motorcycles. It just says it's a higher chance that it's a man. So it's the same thing here. Whatever the question was, if they said yes, the probability it's a woman went way down. Which means less women would answer that question as a yes, right? So this would be no. The probability of a woman is not the same if I knew they said yes. That's what you have to check. I always get people telling me that the probability of yes does not equal the probability of a woman. Why should that matter? Right? What's the probability to flip a head on a coin if it's a fair coin? 50%. What's the probability I roll an odd number on a die? 50%. They're both 50. Does that mean they're somehow intertwined with each other? They're somehow mystically connected? So what? They're both the same. Who cares? That doesn't mean a damn thing. So to see if they're independent, you have to see if one changes the other one. So there's a business course I had to take. And one of the only problems I liked in the course was they said if you know that oil occurs under a certain kind of sand and you want to go drill for oil, then you're going to look for that certain kind of sand. Because given that you found that kind of sand, the probability there's oil underneath is higher. So we use conditional probabilities all the time. We just don't realize. Given that it's after 3:30, do I want to drive home or sit here for a little while? I'm going to sit here for a little while because I know the roads are going to be disgusting, right? So there's certain times in San Diego where you just go, I think I like it here for right now. Let's just stay here for a couple hours, right? And Google, of course, helps us out nowadays. Look at, oh, shit's all red. No? Yes? So we all use conditional probabilities. We just don't think of it in that way. We don't use it fully technically like this, but we use this idea all the time. All right. Let me go ahead and give you guys the answer key. Maybe that'll spur some questions. So I didn't do any from problem number 1 because all the answers should be in the back. That was all review exercises. I didn't really feel like for the practice test actually finding images and putting them on there. On the test, I'll have images, not ones that I've drawn, thank God. I'll should be like, that's a what? That's a trapezoid? Because of my horrible drawing, I understand. So I'll have images from books or whatever, so you'll actually be able to tell what they are. So number 1, all the answers in the book, so you can do that yourself. Number 2, I put up there. I try to fit it all on one sheet so I can save some bother. Oh, that's right, we did that. Okay. So remember I said, so this problem, they're really far apart. It's very easy to see that they're dependent. We talked a little bit about on the practice test, they were really close. So on the actual test, I'll make them either exactly the same or totally opposite so you can tell exactly what the answer should be. Any kind of questions you guys want to talk about? I actually personally don't mind. If you don't have anything you have questions on, that means you understand it all, which is awesome. Yes?
Number 3 on the practice test, like how you got like 3/25, how'd you like solve it? Like why'd you multiply 4/4?
Oh, the easiest fractions. Give me an example of the easiest fraction to make into a percentage.
1/2.
Understood. But in general, like 11% would be what as a fraction? 11 over 100. Is that cool? So obviously, going the other way, if I had something that was over 100, then how do I make that into a percentage? Just replace the over 100 with percent symbol. In fact, if you think about it, put that 1 in between those, and that's a freaking percent symbol. So that means 17 over 100. So if I have a fraction that, like 3/25, can I make it become something over 100 easy? Yeah, just multiply by 4. Because if I can get it to be over 100, the answer is sitting staring me on the top, right? Can I make every bottom easily become 100? No. But if I have something on the bottom like 5, 10, 15, 25, not 15, 20, 25, something that becomes 100 easily, then yeah. I've had people do it, even if it doesn't become 100 easily, just figure out what to multiply by and make it 100, some kind of weird decimal, and it still works. But here I would definitely do it that way. What's the other way to do it though? You can always just do what here? Just divide, make it into a decimal, and then move the decimal place over to make it into a percentage, right? So you got multiple ways to attack all of these. One thing that came up in the quiz for this, why is this, what is a fraction defined to be? I don't know, Jeff, you're the math guy. What is a fraction? I don't know if you guys know this. What's a fraction defined to be? What is it? Give me a fraction. Give me a fraction. Oh, it's crazy. What the hell's that? Yeah, okay, 1/4. Give me another fraction. Give me a bigger fraction.
17 over 32.
Sweet. All right. You would never in your life say 1.78 over 4.29 for several reasons, because you're human. Right? Same reason you wouldn't say I live about 19.384 miles away from you. Right? But the bigger thing here is that's not a fraction. A fraction is a ratio of whole numbers where the bottom's on 0, of course. So what I'm trying to tell you is if I have, what are you trying to say? 1.33%. I can't make that 1.33 out of 100. That's not a fraction. Does that make sense? Cool. So a few of you guys did that. I want to make sure nobody asked me about it. So I didn't know if you really understood why I took points off there. So I go, oh, that's the shit. Yeah, it's not a fraction. So how do you, now here's two things. One thing that's better is just to take it into a decimal, and then you can count what place it's in and put it over that, right? What would this be as a decimal? Where do you have to move the decimal place? Back or forward? Back, right? So once, twice, I got to put a 0. What place is this in? 10,000. So it should be 133 over 10,000, right? Okay, now watch this cool little trick. You don't have to do this ever. Whatever do to the top of a fraction, I have to do the bottom also, right? Multiplicatively. So if I move the decimal over twice on top to make it a whole number, that's effectively multiplying by 100. I have to move the decimal over twice on the bottom. Hey, that's the same stupid answer, right? Whatever you do the top, you got to do the bottom. It's a nice quick way to make a non-fraction into an actual fraction, right? Fractions can't have decimals in them. It's like a hybrid, right? Like a Time Lord diagram. No, okay. So you can't have fractions inside of it. It's like decide what the hell you want to be. Okay. You guys are all like, man, that finish line is staring me in the face, Jeff. Why can't it be now? Yes, sir.
Are we going to be able to do test corrections for exam 3?
Yeah, of course. The only test you can't correct is the final. I always have somebody call me and say, can I come to your office and just sit with you and make corrections? Well, no. Final is appropriately named. So, but everything else you can correct. So if you did not correct quiz 1 yet, you can still correct it and turn it in. If you get enough of them right, you'll get something back. Kind of with me? You're not going to get anywhere near what you could have gotten. Does that make sense? But why do I let you still correct them? Because everything's going to help you out for the final. Final's cumulative. Everything's going to be in the final. You can see that in the practice final. Obviously, the practice final is a bit longer than the actual final is going to be. Are you guys with me? Because how much time do we have for the final? Not that much more time than normal, right? We have 2 hours for the final. So I'm not going to give you a final that's as long as my practice final was. Just in case you're wondering, right? You're like, yeah, my printer was kind of giving out on me, so hopefully you guys can see it. I'll make sure. No, you don't need a Scantron. Yes.
Are we going to have card questions on the test?
Probably not, just because some people don't really know cards as well, and that would be sort of... So I'm going to define something, hopefully something more interesting than blue and green poker chips in a bag. But I'll have something defined So everybody's on a level playing field. If you play cards all the damn time, you know cards, that's a little bit of an advantage over somebody's like, I never see cards. I don't know. I'm always a little surprised that there are people that don't know cards, but it's very possible. Yes?
Is there going to be any questions you want to draw on the final?
On the final?
Yeah.
Could be. How you like that? So I'm glad you asked, though. Even though the practice final is pretty long, it's not necessarily covering everything, or else it would have been this long, right? I would have had volume 1, volume 2 of the practice final. But if you're able to do everything in the practice final well, then you should be prepared for what the final has, right? The best way to study for it is to look at the practice final, but to also look at your old tests, right? That's probably the best, quickest, most efficient way to study for the final. Next Monday, I'll have the answer key for the practice final. Next Monday is the last day of class. Tuesday is when finals start. So don't come to class Wednesday, because I don't know what's going to be happening in here on Wednesday. Probably be other people in here. You'll sit down and you'll take a test on microbiology. I don't know what's going to happen to you. Don't do that to yourself. So you guys are ready for the test? All right, I love you guys. You're looking at me like, I'm not holding you here. This is college. I don't have a key for your padlock. Some of you guys are looking at me like, please unchain me from the desk. But if you have questions, please ask them, yeah. If not, then there's no reason for you to sit there and stare at me.
How do you do number 15 on the final? That's final.
Oh yeah, so that was, remember, the super equals was the most dominant.
Oh yeah.
So the two-sided triangle, two-sided arrow, it's like an equal sign in between the two sides, and then within the first one is the next one is this the normal equals, which is like the arrow.
Yeah.
So that's like the order operations for logic symbols, yeah. Everybody else got the answer key right?
Thank you.
That's the one we just got. That's the official order operation. So what's the word dominant symbol is? And that breaks it up. Next most dominant.
Okay.
561, number 30.
I usually do them.
This way.
Last thing.
That's the first part is straightforward. You remember how a prism is repeated shape? Over it? But now it's what do you find? Part A is easy? So you know part A is also equal to 8. Multiply that to get the total weight of the water. Just to see if it's not going to crash. If you build it, it's going to crash through. Right?
Are we going to have to do all the sections all? Or was there any homework?
Well, we made it up through 12.7. Let me double check. I think it's 12.7. Yeah, 12.7. So you don't have to worry about it. Just 12.7. Yeah. Okay, cool.
You have an extra practice test? Can't find one at the moment.
I have a question on this one.
Perimeter, yeah. What's the perimeter?
But did I use the wrong formula?
No. Area is perfectly fine. But I want the perimeter also. You didn't tell me what that is.
Oh,
Give me the area, but you didn't tell me the perimeter.
Isn't that where you add O?
Yeah, it is. Well, why didn't you? Because I'm asking for the perimeter and the area. You only gave me the area.
I don't know what happened. Okay.
Okay. So, okay.
Thank you.
Sure.